Uh, hello, Firebase Kenya. I hope I'm audible enough and my internet is not flaky. Well, I'm very excited to be here. My name is Kendi J. I am a Flutter engineer and a mobile developer, and a game app developer and a speaker. And this time around, I'm so excited to be here to talk about Firebase Query. And I'm really looking forward to an eventful session to learn and to share a little bit of knowledge and to do a part 1 and a part 2. And yay, let's kick it off. So, what exactly is Firebase Query? What is Firebase even? So, from my understanding, what is the importance of querying? And Firebase querying is a bit crucial for building scalable, responsive, and cost-effective application. And it mainly focuses on performance and cost optimization. By cost optimization is where when you try to run a query, Firebase charges you per query, and then we have data structure indexing, real-time updates, where maybe you're trying to search something and then it updates in real time, and then we have security and access control. So let's try to understand Firestore structure. So here with me, I've done a very simple diagram where we have collections, and then first of all we have sub collections inside of documents, which is inside of collections, and in our collections we named it as users, and then after our collections we have documents. So what does this document store? It stores the user ID, and maybe the user ID has some other things that it has inside it. For instance, in our case, we have a user ID that has a name and has an address. And then in our sub collection, let's say this particular user does some bit of shipping. So it has a document in the sub collection. First of all, it has orders. Sub collections, we've named them as orders. And then in these orders, it has a document which shows which order this particular user is maybe trying to ship, and then how many orders are there. And then we have the status of this particular order or document. So you see how a collection has so many things nested inside it. So I'm assuming you have this big application and you want to do a search of maybe user 300,000. Is there an application that has so many users like this? But yeah, you see, you can't keep scrolling all the way down or all the way up or whatever way. You need to at least implement a search query that you're able to do your own searching so that you get to that user 3,000. Okay, and that's what we're here to learn today. Alrighty, moving on. So with me here, I have a couple of this particular table which displays the many queries that we could be having on Firebase, and there's so many of them, and we'll learn all of them and see some bit of examples, and then later on we'll try to implement them in real time as a code base, as a code lab. Yeah, as a code lab, yes. So these are basic examples like simple queries, compound queries, and all. I'll take you through all these queries with their examples. With me, I have like around 13 of them. So let me tell you more about them. So for the first query, we have simple queries. Okay, so in this particular query, we have it retrieves documents that are much more specific, a specific condition. For example, in this particular query, we are only fetching users who are exactly 25 years old. Here you see we have like the final query where we're fetching it from Firebase Firestore, and it has an instance of collection, and our collection is users, and then from these users we are getting where age is equal to 25. So this is just a very simple query. It's direct to the point. Okay, it's very direct. All right, and then we have the very second one, which are compound queries. So compound queries, they combine multiple conditions using the logical and the way we can use this is to retrieve users who are over 20 years old and they are residing in Nairobi. So we see here we have like two conditions here. We are trying to retrieve users who are over 20, where where age is greater than 20, and where again city is equals to Nairobi. And you see now it's like a compound because we're doing like two queries at the same time. The third one is the or queries. Or queries. Me coming from the other side, R and else. It's a bit of tatanishi, but it's nice to pronounce R. Anyways, so in this particular query, it retrieves documents that satisfy at least one or multiple conditions. This is like a conditional query. So in this particular case, we are only finding users either in Nairobi or they are aged 25. Okay, so this is why we filter um, uh, which is city, which is equal to Nairobi, or age, which is equal to 25. So it's either of those. The fourth one, we number four, yeah. So this is where I had an interesting time, like trying to like decode it. So we have this particular query, which is not equal to and not in filter. Okay. So in this particular type of a query, it excludes documents matching a certain value. Okay. In our case, it fetches active users, excluding banned or guest roles. So in our query here, we are fetching users, of course, in our user collection where the status is not equal to inactive. So meaning the user that we're trying to fetch here is an active user. And then where the role where not in is banned. So meaning this particular guest is not banned. So this particular guest is active and we are excluding the band, or we don't want the band guests. Okay. The next query is an array membership query. So this particular query, it's a very interesting one. It checks if an array field contains a specific value. And if it does, it finds, then it executes what we want it to do. So in our case, we're finding users who are interested in Flutter. I'm assuming all of you here are very much interested in Flutter, because our next session we're going to implement a code that does querying using in a Flutter application. Right. So I hope this is easy to understand, and the code snippets are also very easy to interpret. We have the next one, which is the range queries. So in these range queries, it today I'm having a field day with R's. It retrieves documents where a field's value falls within a specific range. Okay, so in this case, we are getting users between 18 and 30. So if you're below 18, then you won't be found. If you are over 30, then this query doesn't apply to you. So because right now we are trying to retrieve users between 18 and 30. And then we give the output. Righty, moving on. The next one is ordering and limiting results. So this particular query is this is a sort query result and limit the number of documents retrieved. So in our code snippets example, it retrieves the first 10 users sorted alphabetically by name. And then you see here we have the collection users dot order by name, where we limit to 10. So this means that the very first users is what we're trying to sort out, and then we continue to the next maybe. Okay. Yeah, I suppose that was a lot, kinda. So let's move to the next agenda, which is a short break. Anyway, the next type of a query is a pagination. So in this particular query, we are retrieving data in chunks for efficient loading. So you might find you're browsing maybe a website or an application, and then maybe you're scrolling up or down. Yeah, you're scrolling up, and then it gives you an option of load more. So this means that it needs to fetch more of that particular data in that particular page. So in this particular query, it implements a load more functionality in a list or in whatever page that you're trying to retrieve more data. And this particular query is called pagination. Okay, dokie. The next one is aggregation queries. So in aggregation queries, it performs operations like count, sum, and an average on a set of documents. Okay, so in this particular case here, we are trying to determine the total number of users in the collection. So that's why we have dot count, and then on the final, second final, we have final total users is equals to count dot snapshot dot count. So it's dot count because we had already defined it in the count query. Okay, so I suppose this is understandable. So let's move to the next query, which is the collection group query. So when it comes to a connection group query, what this basically means, it's a query that across all collections with the same name, regardless of their location in the database hierarchy. So in this particular case, we are trying to retrieve all shipped orders across different user sublocations. Okay, so we have a collection group in the query. And then the collection group is named orders. And then in this particular collection group, we are trying to retrieve from where we're trying to check the status and if it's equal to either shipped or not shipped, I suppose. So that's basically what a collection group query literally is. It's which example can I show you with? It's like when you're ordering food and then your delivery arrives, or it's even in on the way coming. So it shows you like the particular status of your food request. Yeah, and then if it arrives, then it shows you that you have arrived. Yeah, it shows you something like basically the status of whatever it is that you're trying to order. Okay, dokie. Let's move to the next. The next query is the real-time listeners. So this is a very interesting one. I learned about it today. So this particular query literally listens to the real-time updates on a query results. What do I mean by this? This means that it updates the UI in real time as data changes in the Firestore. So it's like when you're trying to type in something or trying to search something, then it updates in real time. You're able to uh, receive like outputs in real time because it's a real time listener, literally as the name. Alrighty. So the next is a text search query. So this is a very interesting one. This particular type of query performs a prefix-based text searches. What do I mean by this? So it searches for users whose name starts with an A. So we have this particular code here where it shows the collection from users where name is greater than or equal to A. And then, so greater than or equal to A, meaning now this is where we're starting, any name that starts with A or so. And then where name less than or equal to A slash UF8FF. So let me explain what this particular character means. So this character rather is a special Unicode character that ensures the range include all strings that start with the prefix, and the prefix in this matter is the letter A. So yeah, when you're trying to check out somebody and then you type the name, if the name starts with an A, then it's able to bring all the search list that starts with A, something like that. Okay, moving on to the next. So the next type of query is a document ID query. So what does a document ID query Sorry. So a document ID query basically it's a query document based on this particular ID. So let's say, for example, you have users. I don't know. Let me just give an example of, have you ever gone to maybe any of the government offices and then they ask you for your ID number, or even in the bank, they ask you for your ID number, which is a unique user ID, and then they're able to search your information using that particular ID number, and they're able to see you. It could